How can you prevent PyTorch GPU out-of-memory errors? Imagine trying to fit a large puzzle into a tiny box. If the pieces are too many or too big, they won't all fit. That's what happens when your model needs more GPU memory than available. PyTorch is a popular tool for building machine learning models, but running out of GPU memory can stop your work in its tracks. Luckily, there are ways to keep that from happening. First, think about your batch size. This is how many data samples your model processes at once. Larger batches use more memory. If you get an out-of-memory error, try lowering the batch size. For example, if you are using a batch size of 64, reduce it to 32 or even 16. This might slow down training a little, but it keeps your GPU happy. Next, PyTorch caches GPU memory to make things faster. Sometimes this cache builds up and causes problems. You can clear it by calling torch-CUDA empty cache. This releases unused memory back to the GPU. Also, running Python's garbage collector with gc collect helps remove variables that are no longer needed. Doing these steps regularly during training or evaluation can prevent memory buildup. When you are testing your model or making predictions, wrap your code inside with TorchNoGrad. This disables gradient calculations, which are not needed during evaluation. It reduces memory use because intermediate data for backpropagation is not stored. Monitoring your GPU memory is also smart. Tools like NVIDIA's NVIDIA SMI command let you see real-time memory usage. If you notice sudden spikes, you can adjust your code or data loading to avoid overloading the GPU. Simplifying your model can help too. Use fewer layers or smaller parameters if possible. Also, optimize how you load data. Use efficient data loaders that only load what's necessary into memory. This keeps your GPU from being overwhelmed with unnecessary data. Memory fragmentation can be tricky. Over time, small gaps in GPU memory can cause errors even if enough total space exists. You can reduce this by setting environment variables like PyTorch CUDA allocconf is equal to max split size MB 128. This controls how memory is allocated and can help prevent fragmentation. You can also limit how much GPU memory each process uses. With Torch CUDA set per process memory fraction, you specify a fraction of total GPU memory for your process. This prevents one task from hogging all the resources and causing errors for others. Sometimes, despite all these steps, issues still happen. Restarting your training environment or kernel resets the GPU memory completely. It's a quick way to clear out leaks or fragmentation that have built up over time. Managing GPU memory well is not just about making your code run smoothly. It also helps make machine learning more accessible and sustainable. Using resources wisely means less energy waste and lower costs. When working with large models like ChatGPT or DALL, these practices keep everything running reliably. In short, to prevent PyTorch GPU out-of-memory errors, reduce batch size, clear caches often, monitor memory use, simplify models, control fragmentation, limit process memory, and restart when needed. These simple but effective steps help you train and run models smoothly without hitting those frustrating memory errors.